Oh yeah. Okay. That makes it difficult. Makes it harder than it has to be, right? So I get 12x equals 32 times 150, right? Now I actually honestly do this. I don't multiply that out because what's the next thing I would do? I know you guys get a number. You can multiply that out. Who cares? That's the same thing as the number you got. 32 times 150. What's the next thing I'm going to do? Divide by 12. So then I can just reduce this. Right? And you guys are like, I got a calculator. All right. I can do 4 into that, 4 into that. I can do 3 into 150 is 50. 8 times 50 is 400. Same thing you guys got, hopefully, right? Okay. Assuming my brain is working. That's a big assumption. You guys see that? I mean, this is a classic kind of computation problem where you have this ratio and then you have an unknown part. So you set up this cross multiplication thing. It feels like we've done stuff sort of like this before. Here's another classic problem. If it takes 4.8 gallons, can you spell, Jeff? Of paint for, I don't know, 20 square feet. God, Lord. Is there any painters in here that can just totally rip me apart? I have no idea. I have to paint 115.7 square feet. How many gallons of paint will I need? You guys see the kind of the cadence of this problem? This is to this, and then this needs how much? You know, it's kind of a feel to these kind of problems. This is probably one I wouldn't waste too much time trying to do in my head, to be honest. I want to see somebody challenge me. Alright, D. You want to help me? So 4.8 gallons paint needed for 20 square feet. I have to paint 115.7 square feet. How many gallons do I need? So 4.8 gallons for 20 square feet. 20. I like it. So you got gallons over square feet. I like it. Do it. So you don't really have to put the units there, but the only reason I'm doing that is so I don't forget when I go to make the next fraction. The next fraction then must keep the same order. So where does the 115.7 square feet go, on the top or the bottom? Where are square feet here? Where are the square feet here? On the bottom. So where must they be over there? On the bottom. If I get $10 for every hour, I'm going to have hours that if I work for 2 hours, I get $20. Right? I'm not going to suddenly have 20 on the bottom. If I work 20 hours, I get $2. No. So the units tell me what order to put things in. They have to be the same units. Yes?
But I was thinking you can cancel it off, but you don't cancel anything.
How do you mean cancel? Oh, okay.
The unit.
So another way to see this is, yeah, you would cancel. That's actually interesting. So this would be X gallons, right? Over 115.7. I've got to put the square feet down here because that's where they go. Now watch. If you multiply this up, won't the square feet cancel? And then you'll end up in gallons, what you want to be in. There you go. That's why it's got to be the same place, so that when it comes up, it cancels those units out. So if you want to look at it like that, that's beautiful.
Yeah.
If you don't want to look at it like that, wherever that thing is there, it better be the same place over there. That's the only way it's going to make sense. This is a G, by the way. Don't worry, this is little units. So then I can just multiply, cross multiply, right? So you get 4.8 times that, whatever the hell that is, equals 20x. And then I just divide by 20. I don't know. 30, 26 points now. $25, 20 something? Somebody done that yet?
27.768.
I got close. So you'd probably go to the store and buy 30 gallons just to be safe. Do you see what I'm saying? I wouldn't go and say, I need 27.768 gallons. Exactly. You'd get 30 just to have some left over for repairs or whatever. You guys with me? If you've never painted before, then you can still do the math. But if you have, you know what I'm talking about. With that same color, or else you're never going to match the color again, ever, in your entire life. They can never match it perfectly. Too bad for you. You better have some left over. Alright, so every problem we just did, they're all exactly the same problem. They're the same problem, just different numbers being used to protect the innocent. There you go. Oh, exactly. Yeah. So that's what I was saying. You don't want to buy exactly this much. Maybe double might be too much, but you want to buy a few more gallons than this, so you have some left over. Totally. Good. Okay. So we're going to get just a little bit into chapter 7, and then going to let us out. Maybe a little bit early to see how I'm feeling. By the way, when's our next test? I'm not saying. I'm not asking for suggestions. I'm saying, when is it already set? Next Thursday. So a week from this Thursday is our next test. It's only going to cover. It's not going to cover all of chapter 7, so don't freak out. So this Thursday we'll find out how far it's going to cover. So next test is a week from this Thursday. It's going to cover section 5, 6, I believe, is where we left off after last test, up to something in chapter 7. So we'll see how far we make it. Everybody take a collective college. All right. Way to get to my dreams, damn it. What's that? I'm sorry?
Is it November?
I forget the exact day. I just know it's a week from this Thursday. Whatever that is. November 10th, yes. 2 days after Election Day. 2 days after we maybe see what the hell we've done to ourselves. What's up?
It might be in a pricing that day.
We'll see. All right, let's see. Oh, so now that we've talked about all the different types of numbers, or a decent amount of types of numbers. We got decimals and fractions and whole numbers and integers and all that stuff. Now we're going to take a step back and look at all the real numbers and how they act. So I keep saying this word, real numbers. You keep using that phrase. Do you not think you mean what you think it is? So, there are things called, unfortunately, let me tell you this. When they came up with the idea of negative, there were mathematicians that said, that's preposterous, that's bullshit. What is it? They might have said bullshit, they said whatever was that day's exclamation. Preposterous, whatever. So people rebelled against this. They wanted to call these something like fake numbers, made up bullshit numbers. Nowadays, we know all too well that we desperately need negative numbers, right? We need negatives to describe my bank account sometimes, to talk about temperature in certain areas that are not here, but so obviously negative numbers are not imaginary, they're not made up, they're not fake, they exist and they also. So unfortunately there are numbers, people had the same problem with them when they were invented, when they were thought up, and they called them imaginary numbers and that name stuck. They just never changed the name. So when you get to a certain level in mathematics, you're going to talk about something called imaginary numbers, and that is where students go, I freaking knew it. Make this shit up every day. As you did, just off the top of your head, that sounds good. They'll never know. No, it's just an unfortunate historical leftover. When people first saw them, like, that's crazy, and nowadays we're like, we couldn't do a lot of what we do without these so-called imaginary numbers, believe it or not. We're not going to talk about those any more than I just did in this class. We're going to stick with... Were you guys curious about that? Oh. There's some people going, oh. But you're just doing that for my benefit only. So, what are the real numbers? Well, they're made of... They're made of... The smallest little group in here are called the natural numbers. And these are the ones that came naturally to us. 1, 2, 3, so forth. Yep, exactly. Continue in that manner forever, basically, is what the natural numbers are. And I think I've talked to you guys before in this class about the whole numbers. There are whole civilizations that had no idea, no concept, no symbol for zero. The idea of zero had to be created, which is a weird thing for us. We live at a time when a lot of shit's been created and made up. We just do. We don't live in the time before it was. So when I say it had to be created, you're like, what are you talking about? I knew about zero for... No, that's because it's already been made by the time you were born. So yay for you. So this will be 0, 1, 2, 3. So every time I do something outside of that, it's going to add something. So the whole numbers are all these numbers plus 0. And their name is nice. Whole numbers include the number that looks like a hole. Right? Nice way to remember. Cool. The next step out, and sometimes I like to have this little story as I'm doing this. So I'm a caveman. I've got my one rock. I'm all happy. My one rock, I can do so much with this rock. I can get food. Go eat that duck and whatever. And then I lose my rock. So I got to come up with the idea of 0. And then I have to borrow a rock. So then I have to come up with the idea of negatives, integers. Integers are all these numbers plus their negatives. So it'll be negative 3, negative 2, negative 1, 0, 1, 2, forever. Forever down, forever up. So we've used that word before, integers. We've used the word whole numbers before. I think I might have said natural numbers before, but I can't remember. They're also called counting numbers. 1, 2, 3, 4 makes sense. This is nothing amazing. This is just names we gave to certain groups of numbers. But it kind of mimics how they were created. And the next step out, what comes after integer? What's the only thing I'm missing now? So I borrow a rock. So now I'm down, I owe somebody a rock. I borrow a rock, and I'm tripping along, and I trip over something, and it falls out of my hand, and it breaks in. So I got to come up with fractions, right? Wow. And a fraction is a ratio of two whole numbers, where the bottom is not two integers.